Alright, the next thing that we want to talk about is dividing complex numbers. We've looked at addition, subtraction, and multiplication. So the last thing that we will talk about is dividing complex numbers. Now, anytime you take the quotient of two complex numbers, that quotient is going to be a complex number itself. So basically, if you divide two complex numbers, your quotient, your answer, has to be a complex number too. Now, to write the quotient as a complex numbers, you have to eliminate the I from the denominator by using conjugates. Okay, so anytime you are trying to divide complex numbers, you need to eliminate the I from the denominator, and the only way you can do it is by using conjugates. Again, why do you use conjugates? Because we just saw what happens when you multiply conjugates. You saw that when you multiply conjugates, you get rid of that I and you just end up with a real number. There's no I left in your answer, and that's why we will use that same idea here when you are trying to divide a complex number. So let's look at this example here. You have 29 divided by 5 plus 2i. So the first thing you will do is multiply both your numerator and denominator by the conjugate of your denominator, so that you can get rid of that I in your denominator. Okay, so multiply them by the conjugate of the denominator. Okay, so let's see how to do that. Okay, so you have 29 over 5 plus 2i. You multiply by its conjugate. Again, remember, conjugate is where the terms are the same, only the sign in the middle changes. So this will have i, and multiply the numerator and denominator by that conjugate. So let's see what we will end up with. You have 29 times 5 minus 2i, and your denominator will be 5 square plus, remember I'm using that a square plus b square idea here, so 5 square plus 2 square. Okay, and let's see what we will come up with. Okay, 29 over times 5 minus 2i over 5 square will be 25. 2 square will be 4. And that will give you 29 times 5 minus 2i. Now go ahead and combine your denominator. 25 plus 4 will give you 29. And of course you can see you have a 29 in the numerator, 29 in the denominator. Cancel those out. And your quotient is going to be 5 minus 2i. So that's what we were saying, that when you take the quotient of two complex numbers, it is always a complex number too. So there you end up with 5 minus 2i. If you realize, this is almost very similar to what we did with rationalizing the denominators. And you use the conjugate there also when you wanted to get rid of your radical terms, and here since we want to get rid of I, we're kind of doing the same thing as we did there. And again, your final answer, you will see, is in the standard form. Okay, let's look at more examples. Now here you have negative 38 minus 8i, and this is being divided by 7 plus 3i. So Again, you start out by multiplying with the conjugate of the denominator, which will be 7 minus 3i. Okay, so multiply both your numerator and denominator by this conjugate, and you will end up with, let's see, negative 38 minus 8i times 7 minus 3i. And on your denominator, that will of course be 7 square plus 3 square. Okay, now you will have to FOIL your numerator, so go ahead and multiply these. Negative 38 times 7 will give you negative 266. Then you multiply negative 38 into into negative 3i. Negative 38 into negative 3i will give you a positive 114i. Okay, then you will multiply the negative 8i into 7, which will give you negative 56i, and negative 8i into negative 3i will give you a positive 24i square. Okay, your denominator will be 7 square is 49, 3 square is 9. Okay, now go ahead and combine your numerators together, and you will end up with negative 266 plus 58i plus 24 minus 1. Again, I square will become negative 1. Your denominator will be 58, 49 plus 9. And this will give you negative 266 plus 58i, and 24 times negative 1 is negative 24 over 58. Okay, now you can combine negative 266 and negative 24. They're both real numbers, and that will give you negative 290 plus 58i over 58. Now, you can see that you have 58 common between the 58i term and the denominator, so you want to try and see if you can divide 290 also by 58 and see what you end up with. So go ahead and try this. 290 divided by 58 plus 58i over 58, and you will see that you end up with 290 divided by 58 gives you 5, and then you have the negative there, negative 5, and then 58 will go into 58 once, so you're left with I as your answer. So negative 5 plus I will be your answer. The other thing that you could have done is on your numerator, you can see that between 290 and 58, 58 will be a common factor, so you can pull that 58 outside, and that will leave you with negative 5 plus I in the parentheses, because when you divide 290 by 58, you end up with 5 and you take the negative sign with it, and 58 divided by 58 leaves you with just 1, so that's why you just have the I by itself, and then 58 in the denominator, and the 58 and the 58 cancel out, and you're left with negative 5 plus I also. So either way, you can see that you end up with the same answer of negative 5 plus I. Alright, let's look at 3 plus I over I. Okay, in this case you can see that you don't have a complex number in the standard form. You have just one I by itself, so if you want to get rid of I, the only thing you can do here is multiply by I itself, because we know that I squared gives us negative 1, and you can get rid of I in that way also. So you will end up with I times 3 plus I over I square, I times I. Okay, and this will of course give you 3I plus I times I is I square, and denominator of course becomes negative 1. Now 3i plus again I square is negative 1. So you will end up with 3i plus and minus will of course give you minus 1 over negative 1. Now since you have 3i minus 1 over negative 1, you can basically say this is the same thing as saying negative 3i minus 1 over 1, where you just take the negative from the denominator, put it on the numerator, and anything over 1 is that number itself, so negative 3i minus 1, and you can go ahead and distribute that negative sign, and it will give you negative 3i plus 1 as your answer, or you can write it as 1 in the front minus 3i as a second number, and that will be your answer in the standard form. Okay, a plus bi. So anytime you see just a single I or maybe even a negative I in the denominator, just multiply the numerator and denominator by I itself. Alright, and just the last thing that I want to talk about in this section is actually something really simple, what we call as the powers of I. Now we know I square is negative 1, so you can try and use that information to find any power of I. So we'll look at a couple different powers here. Now let's say we wanted to find out what I to the third is, so we can use our rules of exponents here and write I to the third as I times I to the second. So 1 plus 2 of course gives you 3. Now I stays the same, but we know that I square is negative 1, so that will give you negative 1 times I will give you negative I as the answer. So I to the third is equal to negative I. Try doing the same thing with I to the fourth. I to the fourth, you can write that as I square times I square. Again, 2 plus 2 gives you 4, and that will basically give you negative 1 times negative 1 for each of the I squares, and negative 1 times negative 1 of course gives you positive 1 as the answer. So it's really as simple as just breaking these powers down. Now for I to the fifth, you can try and do this as I to the fourth times I, because we already found what I to the fourth is, so we can use this information to help us out here. I to the fourth is 1, I stays the same, so that tells me I to the fifth is equal to I. Okay, let's move on to I to the sixth. For I to the sixth, you can again try and do the same thing that we did here. Use I to the fifth times I. 5 plus 1 gives you 6. I to the fifth we just said was I. Okay, and then this I gives you I times I, which we know is I square, which will give you negative 1. Okay, so just keep following that. And for the 7 and 8 also, you will notice for 7 you end up with, let's see, we can try and use I to the third times I to the fourth for us. 3 plus 4 gives us 7. And then just use this information here to help us out. I to the third is negative I to the fourth is 1. So I to the seventh will be negative I to the eighth, we can take it as I to the fourth times I to the fourth, which will be 1 times 1, which will give you 1. Now here you will notice that your I to the second is negative 1, I to the third is negative I to the fourth is positive 1, and I to the fifth is positive I. And you start that cycle again. You go from negative 1 to negative 1, negative I to negative I, positive I to positive I. And this is true for powers of I. They rotate through these 4 numbers: I, negative 1, negative I, and positive 1. Okay, so if you go on to find I to the ninth will be the value I. Alright, let's go ahead and we'll go ahead and try to find each one of these powers of I. We'll start with I to the 18th, and we'll see how this information that we just worked out earlier can help us. So I to the 18th, you can try and write this as Just look at examples here. Let's see. I to the 8th times I to the 8th. So 8 plus 8 we know gives us 16. And I to the 2nd. Okay. So 8 plus 8 gives you 16. 16 and 2 added together give you 18. Now I to the 8th we just saw here earlier is 1. So I to the 8th is 1. So both of these will be 1s. I to the 2nd we know is negative 1. And 1 times 1 is positive 1 times negative 1. And I to the 18th in value is going to equal negative 1. Try doing something similar for I to the 89th. And let's see what you can break this down into. You can write this as I to the 80 times I to the 9th. Okay, 80 plus 9 will give you 89. Now I to the 80, if you choose, you can write it as I to the 8th times 10. Okay, because 8 times 10 will give you 80. We know I to the 8th is 1. So basically we are saying 1 to the 10th times, and I to the 9th will be I. Okay. Because again, you know, we go through the whole rotation, so you can try and figure out that I to the 9th is going to be I. And this 1 to the 10th power is still going to be 1. 1 times I will of course give you I as the answer. So you're using rules of exponents to help you out here. Now here you can see that you have a negative exponent. So I to the negative 17th, go ahead and make it a positive exponent by writing 17 in the denominator, I to the 17th. And now you can go ahead and simplify in the denominator. So you can write your 17th as, let's see, I to the 10th times I to the 7th. Okay. Now let's see what I to the 10th would be. Now since I to the 9th was I, we said that you go through the rotation. So if I to the 9th was I, that tells you that I to the 10th is going to be negative 1. Okay, and then we said that I to the 7th was negative I, so you will end up with 1 over negative 1 times negative I will give you positive I. So 1 over I is going to be the value for I to the negative 17th. Okay, so there's many different ways that you can do these powers of I. Just go ahead and use whatever combinations you like, and you will still come up with the same exact answer. And this will be the end of section 10.7 and end of chapter 10.